All right. Thanks for putting up with me and the 4 videos for how to build a VPN in 4 easy steps without spending a penny. It's been an adventure making those videos. This is the final one. I wanted to show you a few troubleshooting things I learned along the line while I was making these videos. They will help you when you go to implement this. And so one of the biggies right up the bat is, well, let's say the server doesn't want to start. Well, what could possibly be the reason? Well, here's the in Linux these days we use a facility called systemctl. And before I go any farther, let's get off my talking head and let's go to the screen. So let's not make the mistake I made 4 or 5 times there in step 4. So let's go to the screen and let's minimize that mirror within a mirror within a mirror. So let's say the server doesn't want to start. How do we troubleshoot it? Well, first things first. One of the biggies and what messed with my mind more than anything were names of files that were out of place. We have a few certificate files and we have configuration files. You have to have the right files in the right directories. So let me show you how this works. There's a facility called systemd in Linux these days, and there's a command called systemctl. And so the general form is systemctl, start, stop, or status, and then the name of the service that we want to do. Now OpenVPN is called OpenVPN-server at, and then the configuration file name .service. And I'll show you where the unit file for that lives, and the unit file controls how this thing starts up. Very first thing, number 1, make sure that syntax is right for the name of your file. Now, the system services all use these unit files, and unit files live in /etc/systemd or user live systemd system, and I have that somewhere. I'll just go paste it in. We'll get to that in a second. I'll get to that when I get to that. The certificate names and key names, this is where they all go. Make sure your files are all in the right directories. If they're not, you'll have a mess. And here's where the unit files go. User live systemd system. Let me show you that. Right here, right there, like that, and cat. Let's paste that in. The thing that's important about that is right here, the working directory. Right here, working directory. Etsy OpenVPN server. That's how we know where everything starts, because this unit file specifies it. There's a whole body of knowledge. If you want to use a different working directory, there's a way to do that. That's beyond the scope of this tutorial, but call me and I can help you through that. So this unit file defines how the service starts, and then the configuration file that we store in Etsy OpenVPN server defines its operating parameters. That's how it works. Make sure your files are all in the right place with the right names, and use that automation that I put on my website to put some of those things in place. That will save you a ton of grief. I've done the troubleshooting already and automated much of it. Windows client problems can mess with your mind too. The C program files, OpenVPN config, that's where all your stuff goes inside Windows. But even if you are a local administrator on your Windows computer, you can't manage that directory. You have to be the administrator to do that. And so that's why I set up WinSCP to run as administrator, and why we had to do a command window to run as administrator and launch Notepad from there so we could edit our stuff in those directories. That's why. Integration issues can bite you too. Make sure user and group OpenVPN own all those files on the server. Remember that directory I showed you in step 3. OpenVPN needs to own all that stuff, because the daemon runs as user OpenVPN, not as root, so that in case somebody out there exploits a bug and causes damage, they won't have the ability to destroy the whole server. That's a big deal. Make sure the compression settings and MTU settings match on both the client and server configuration files. Funny thing about that, if the compression settings don't match, nobody can talk to anybody else. So what happens is It's the bizarre symptoms. What happens is the client connects to the server. The server downloads all the routes and stuff. The routes look good, but then nobody can ping anybody. Then after a while, then after 30 seconds, which is the timeout, then the tunnel dies and connects up again. And you'll scratch your head on that for hours and hours and hours. Remember that LZO thing I showed you. Make sure the compression is the same on both sides of the tunnel. Otherwise, they won't talk to each other. Now, the MTU, the maximum transmission unit settings, make sure they match too. The ping program is your friend. From the client, you can ping different systems inside your company network, just like we did in step 4, and that can tell you whether things are good or not. Start close to where you are and work your way farther out. So you'll ping 10.8.0.1. That's the OpenVPN server. If it answers, you know the tunnel is good and you know the server is good. The next thing is ping something on the other side of 10.8.0.1. If you're not able to talk to that, you probably aren't sending the right routes down to your client. So that's where you look first. Make sure your company firewall forwards and NATs UDP port 1194. So your firewall advertises your open asthma again. Your firewall advertises your OpenVPN server on a public IP address, but the OpenVPN server lives inside the firewall. So the firewall NATs it, NAT, a network address translation. The firewall NATs it from the public IP address to the private IP address, and anything UDP 1194 sends over to there. Set your firewall up accordingly. You saw the settings for how I did mine. The TCP dump program on the server is your friend, and I'm going to show you a quick demo of that. We need 2 windows. We've got a window here, that's our OpenVPN server, and I have another window I should have. That's my firewall. Now, watch this. You've got you're the system administrator, or maybe the company owner, and you've got somebody 50 miles away who needs to get into the office over this VPN, and something doesn't work right. So how do you troubleshoot that? Well, first, have them go, make sure they can connect to the internet on their end, which they should be able to do. Have them go to Google, and everybody knows how to Google these days. And in the little search thing, type my IP. Just type that, and that will return their IP address. Google will tell them their IP address. Now here's mine, 216.16.2.129. That's my IP right here on this workstation inside my company. I still have my laptop connected from step 4, and so I've looked at its IP, 174.219.20.224. Now watch what happens here. I'm on my firewall, and let's look at any traffic in and out of that tunnel from my firewall's point of view. Let's just look at that right now. And there's nothing. On my laptop, I'm going to ping 10.10.10.10. Remember the ping program? And that's just some tunnel stuff. Well, that's not not anything exciting. But watch what happens here. I'm pinging. Notice see the echo replies, echo request, echo reply. Well, just see the echo replies. See those? Now let's do the same thing on my OpenVPN server. Let's look at that stuff let's look at traffic on the OpenVPN server from the outside of the world. And let's do our pings again. You see a bunch of control traffic and a bunch of UDP 1194 stuff. Watch this. Here, press enter on my pings. Look at that. That's the request and reply, but you don't see it that way because it's all masqueraded there. See that? But let's look at this. Let's abort that. Let's abort that. And the laptop is 10.8.0.2. So let's look at ENS3 host 10.8.0.2, and let's do minus there. All right, minus ENS. All right, now let's do our ping again from here, and well, here, wait. Do it right. Let's look at everything in the whole network. Let's do net net 10.8.0.0/24. Let's just look at everything inside the tunnel here. Let's see what happens. There we go. Look at that. Echo request, echo reply. You can follow that. You can follow these packets all the way through. And if you've got a network sniffer, if you've got switches that can mirror what's going through their ports, that stuff can be an invaluable troubleshooting tool. So tools like ping and TCP dump and traceroute, familiarize yourself with those tools, and they will help you enormously when you're helping your people from far away get into your company network. All right, possible next steps. There is a whole bunch of ways I could have implemented this. One possibility is to set up for two-factor authentication. I used a certificate password, but I could have chosen to do this with an Active Directory password. What does that mean? Well, the way I chose to implement this, your users are going to be inconvenienced because they're going to need to know two passwords. They're going to need to know the certificate password to get into the VPN, and they're going to need to know their Windows password to log into your Active Directory. They're going to need to know two passwords. That'll be inconvenient. There's a way to pull this off so that they only need to know one password. You set your OpenVPN server up to integrate with the company's Active Directory, and then you call the right plugin programs, and then when your users connect, the password prompt is for an Active Directory password, not for a certificate password, and the authentication happens on the server, not on the client when you're trying to decrypt the certificate. Subtle difference, well, not so subtle internally, but that way the users only have to remember one password. Another way to do it is to eliminate certificates entirely on the clients. Certificates on the clients give you a problem because somehow, some way, you need to get those certificates onto the client PCs. The way I did it for our demo was I connected my laptop into the internal company network, I copied the certificates to it, and then I went away on the other side of the cellular phone company network. That way can work for people that are geographically close, or they can mail their laptops in. You can configure the laptop and mail it back. That kind of stuff could work. Another possibility is put the certificates into some sort of a download area of some kind, maybe a Dropbox or something like that. Put them in some secure location so the people that need them can get them, and give them instructions for how to download and copy them where they need to be. That's another way to do it. Any way you look at it, getting those certificates onto your people's computers all around the world it's just gonna be a little bit of work. There's a way to do this without certificates and using a device called a one-time password generator. The idea is you set your server up to use that Active Directory or use your LDAP your LDAP store of your LDAP directory of users. And then you have this device called a one-time password generator. You sync that device up with the server and give every user one of those devices. They enter their Active Directory passwords, they tap a thing on the one-time password generator, and they put that in, and that's how they connect to the VPN. It's good security, it's good two-factor authentication. It's a royal hassle to set up those one-time password generators. I chose this approach for this implementation because it's the simplest to build, and I can get it up and running, and I can present it in a few days. If anybody out there wants to do an Active Directory one, or has a way to do the one-time password one, where it's well documented and works, I'm all ears. I'll be happy to take your input. And that leads to the next thing I want to talk about, and that's an open source development method. With an open source development method, a project has a champion who puts it together on a volunteer basis. Other people from the community contribute to the project, and the champion helps coordinate what goes in and when and releases and stuff like that. If a community develops for this, there's already a healthy, huge open VPN community. If a sub-community develops for implementing this thing to get us through a global pandemic, I'll see what I can do to keep your updates incorporated in what we do. This will be a documentation and implementation project and an education project more than anything else. That's open source. We collaborate. We stand on each other's shoulders, and we stand on the shoulders of giants, and we collaborate, and we iterate. So we start somewhere, people contribute, we make a next version, people contribute, we make a next version, we release early and often, and eventually we have something really, really, really good that will run rings around anything the other rest of the world can do. That's open source in a nutshell. It's a powerful way to build stuff. I am a Red Hat employee, but I am not representing Red Hat with this procedure. I'm representing myself. I did all this on my own equipment, at my own house, on my own time, and so any errors or omissions or any of that are mine and not Red Hat's. But I am indebted to some friends inside Red Hat who helped me with configurations and helped me with advice on some of this stuff. So thank you for that. But I am not. I'm not representing anybody but myself. I need to say that this comes without any warranty of any kind and no official support of any kind. You're not on your own. I'll answer questions as to the best of my ability, and if we develop a community for this stuff, we'll have multiple people answering questions. But this is community stuff after all, and it's free. Hopefully, this is worth a little bit more than what you paid for it. If you find this helpful, one more favor, if you find this helpful, I would appreciate it if you'd consider buying one or more of my novels for everybody in your department or in your company. Let me show you a few of, I'll show you the books here. These, there you go. Bullseye Breach, Anatomy of an Electronic Break-In. During the Christmas 2013 shopping season, Russian mobsters broke into the corporate network of this huge retail in Minneapolis named Bullseye Stores, and they stole 40 million customer credit card numbers. Well, Jerry Barkley is just a bald-headed IT contractor here in the Twin Cities, and he helped put a stop to those guys. They came up with a creative way to fight back. Read the book for details. In Virus Bomb, Jerry Barkley finds himself in the middle of the largest cyber attack in history, and then that cyber attack turns out to be a data gathering phase for a really, really, really nasty biological attack. Problem is, nobody believes Jerry's warnings because, well, he's just a bald-headed IT guy. He's never worked for the government, and only people who work for the government know anything about cybersecurity, right? Well, that's about as wrong as it can get. Don't get me started on that. Jerry Barkley is no superhero. He doesn't have any superpowers. He never worked for the government. He doesn't know anything about counterterrorism. But he's the guy that's got to solve this thing. And that made me think about some stuff. Real superheroes don't need superpowers. Real superheroes are ordinary people who step up, even when they don't want to. And that leads to one last thought. I'm going to show you this PDF. One of the things, it was suggested when I published Virus Bomb that I need an epigraph. An epigraph is a quotable quote that somebody famous said that just kind of sets the tone. Well, I made up my own epigraph. Here it is. And anybody who's an IT professional you'll grin at this because we know what I mean. An IT professional's job is like stocking toilet paper. Nobody cares until there's an outage. I love that saying, and I'll keep repeating it as long as we're all stuck at home here in the middle of a toilet paper shortage in the middle of a global pandemic. Thanks for putting up with my 4 steps, and I hope you find them valuable, and I hope you put them to work. Build some VPNs, teach your people to be more productive while they're out and away from the whole world. We'll come through this global pandemic stronger and healthier, stronger than ever, and healthier than ever too. So thanks for putting up with me. Time to stop recording.